Fine. So very good day to everybody. This is Computer Communication Networks, and in this class we discuss about TCP, Transmission Control Protocols, about its services, features, and how you establish a TCP connection. So this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again let me thank God for giving me this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students, and young researchers. So in this class, we will have a short introduction towards Transmission Control Protocol. Then we discuss about TCP IP layer. We discuss about the working of TCP. Then we discuss about the features of TCP IP, Transmission Control Protocol, Internet Protocol. Then we discuss about the services and segment structure in TCP. We discuss about the services of TCP, about the byte number, sequence number, and acknowledgement number. Then we discuss about the segment structure of TCP. Finally, we are going to end this class with the header length and control flags. Okay. So I have already given the independent work for you. Please complete them. And at regular intervals, I will be giving you some short videos to discuss the knowledge in our topics. So this is Transmission Control Protocol. Actually, it's one of the main protocols that you can use it for the IP suite. Okay. So between the application layer and the network layer, you will be having several requirements of reliable delivery services. So you can say that TCP, Transmission Control Protocol, is a connection-oriented protocol, especially for communication that helps in the exchange of messages across or maybe between different devices of a network. Okay. So from this you will be getting a synchronization. Okay. Then you will be getting an acknowledgement. Okay. So after receiving this one, once again you send the acknowledgement that the the data packets has been received. Okay. So here we will have application layer, transmission control protocol. So this is the transport layer we are talking about. Then we will have internet protocol. Then we have the network layer. So in order to make sure that every message reaches its target location, so the TCP IP model will be breaking the data into small bundles and it will be reassembling the bundles into the original message on the opposite end. So which means that you are going to send the information as small amounts of information. So definitely you can maintain efficiency across the network, and you can whenever you are sending the data, you can actually maintain the efficiency. So after this particular message has been broken down into smaller segments, so the bundles will be traveling across multiple routes. If one route is maybe jammed, but definitely your destination remains safe. Okay. So this is how the data packets has been sent across the network. Okay, so through the internet it has been sent. So it will be taking multiple alternate routes as well. So when the user requests a web page on the internet, so the server will be processing that request and it will be sending back a HTML page to that user. So the server will be making use of hypertext transfer protocol, and here the HTTP will be requesting the TCP layer to set the required connection, and it will be sending the HTML file. Okay. So the TCP will be breaking the data into small packets and it will be forwarding towards the internet protocol layer. So as I told you, it will be taking multiple layers or maybe different routes. So the packets are being sent to the destination through the different routes, and here the TCP layer in the user system waits for the transmission to get completed, and it will be acknowledging once all the packets has been received. Okay. So these are the features of TCP IP. We will be having segment numbering system. So TCP will be keeping track about the segments being transmitted or maybe the segments being received. Okay. By assigning some numbers to each and every one of them. Okay. So this is a specific byte number that is being assigned to this data bytes. Okay. So whenever it is being transferred, it will be assigning a byte number. So which means that the segments are assigned the sequence numbers. So here acknowledgement numbers are also assigned in order to receive the segment. So maybe if you can see from client to server, so active open, passive open. So synchronization segment, then you will be getting synchronization plus acknowledgement, then you will be sending acknowledgement segment. Okay. So flow control, it will be limiting the rate at which the sender is going to transfer the data, and this is being done in order to ensure the reliable delivery. Okay. So maybe if you have to continually maybe inform the sender about how much data can be received, you can use a sliding window. Okay. And also you can go for error control mechanism also for reliable data transfer. Here error control is actually byte oriented, which means that the segments are checked for the error detection. Okay. So here the error control will be having corrected segment, last segment management, out of order segments, and then duplicate segments also. Okay. And then we'll have congestion control. So here it is going to take account of about the level of congestion in the network. So here congestion level is determined by the amount of data which is sent by the sender. Okay. So you can say that it's a reliable protocol, and error checking is also there. It gives flow control, and it makes sure that the data is going to reach the proper destination in the exact order wherever it is being sent. Okay. And this is an open protocol which is not owned by any organization, and it is not owned by any individual. So you can say that it is going to assign an IP address to each computer on the network, and it's going to assign a domain name to each of the site that it is going to differentiate across the network. But disadvantages, it is made especially for WAN, wide area networks, which means that its size can be an issue for small networks with lower resources. Also, it is going to run several layers. So since it is going to take multiple routes, it is going to go for several layers, which means that it is going to slow down the speed of the network. Okay. And of course, you can say that it is not generic in nature, which means that it cannot represent any protocol stack other than the TCP IP suite. Okay, which means that it cannot work with a Bluetooth connection. Okay, so that is a disadvantage we have here. Also, no modification has been done since 30 years. So that is also one of the biggest problems. So transmission control protocol, you can say that it is the most common transport layer protocol. Definitely it is going to work with IP, and it is going to provide a reliable transport service. Okay. So various services, we can say that it's process to process communication, which means that transfer of data takes place between individual processes which are executing on the end systems. Okay. And it is done using port numbers or port addresses. So here the port numbers are 16 bits long, okay, which means that it is going to identify which process is actually sending, or maybe which processing is receiving the data on a host. Okay, so this is how the TCP is going to send a stream of bits. So this is the sending process, and this is the receiving process. Then we have stream oriented, which means that the data is sent and received as a stream of bytes. Okay, unlike the user datagram protocol or maybe internet protocol, which is going to divide the bit into datagrams or maybe packets. So here the network layer, which is going to provide services for the TCP, sends packets of information but not streams of bytes. Okay. Here TCP is going to group a number of bytes together into a segment, and it is going to add a header to each of the segments. And after that, it is going to deliver the segments to the network layer. So on that network layer, each of the segment is going to encapsulate in an IP packet for transmission. Here the TCP header has information that is required for control purposes. So definitely, for example, if you take the case of full duplex service, which means that communication can happen in both the directions. Okay. And of course, you have connection oriented service. So UDP, it's a connectionless protocol, but if you take in the case of TCP, it provides connection oriented service. So here we will be having three phases. One is connection establishment, data transfer, and then connection termination. Okay. So here if you say reliability, definitely it is going to use the checksum. It is going to check for error, and it is going to recover the lost or maybe the corrupted packets that is carried out by retransmission, acknowledgement policy, as well as timers even. Okay. So here we will be having byte number, sequence number, and acknowledgement number in order to ensure the reliability. Also here, in order to ensure reliability, we will have congestion control mechanisms. We have multiplexing also. So manipulating like multiplexing and demultiplexing at the sender and receiver. Okay, we will be having number of logical connections that is being established between the port numbers. So this one you are going to establish using a physical connection. So in order to ensure the reliability, we will have byte number, sequence number, and acknowledgement number. Everything has been transmitted and numbered as well. And beginning of this numbering is just imaginary. Okay. Sequence number, you are going to give it to the segments, which means that you are going to reassemble the bytes at the receiver, and even if they arrive at a different order, you are going to you are going to number them and reassemble them. Okay. So here the sequence number of the segment is nothing but the byte number of the first byte that is being sent. And then you'll have acknowledgement number. So this is actually required when the TCP is providing the full duplex service. Okay. And here acknowledgement number is the next byte number that is the receiver is going to receive, which also provides acknowledgement for receiving the previous bytes. For example, from A to B, we will have sequence number, acknowledgement number, byte number. And similarly, in reception, you will be getting a sequence number, acknowledgement number, and byte number from the B. Okay. So here, if you can see, A is going to send an acknowledgement number 1001, which means that it has received the data bytes till the byte number 1000, and afterwards it will be expecting to receive the 1001. Okay. Then afterwards, B is going to send the data starting from 1001. So this from 1000, this from 1001. Okay. So similarly, since B has received data bytes till the byte number 13001 after the first data transfer from A to B. So B is going to send an acknowledgement after receiving 13001. It will be sending 13002. Okay. So that's the byte number that it is going to expect to receive from the A next. So here we'll be having the segment structure. We'll be having header, data, source port address, destination port address, sequence number, acknowledgement number. Then you'll have header length, reserved bits. Okay. Then you'll have the corresponding bits, window size, checksum, urgent pointer, options, and padding up to 40 bits. Okay. So the header will be having the range from 20 to 60 bytes, and for options we have 40 bytes. So if there are no options, means a header is generally 20 bytes, else it can have up to 60 bytes. So these are the header fields. We will have source port address. So you will have 16-bit field, which is going to hold the port address of the application that is going to send across the data segment. Then you will have destination port address. It's a 16-bit field that holds the port address of the application that is actually receiving the data segment. Then you will have sequence number. It's a 32-bit field that is going to hold the sequence number. So that is nothing but the byte number of the first byte that is being sent with the particular segment. Also, it is going to reassemble the message at the receiving end that is received out of order. And then you will have acknowledgement number. Acknowledgement number, it is 32-bit field. So this is the byte number that the receiver expects to receive next. So it's an acknowledgement for the previous bytes being received successfully. And then you will have H length, header length. So it's a 4-bit field. You will be having the length of the TCP header. That's actually the 4-byte words that is going to specify. For example, if it is 20 bytes, that is actually the minimum length. Actually, it can have a maximum of 60 bytes. Okay. So 20 bytes, that's the minimum length of the TCP header. So which means that it will be holding 5, which means that 5 multiplied by 4. So that's actually 20. And maximum length, as I told you, is 60. So that's actually 15 multiplied by 4. It is actually 60. So here the value of the field can range from 5 to 15. Okay. And then you will have control flags. So which means that there are 6 1-bit control bits. So in order to make the control connection establishment, you will be using control flags, especially for control connection establishment, control connection termination, connection abortion, okay, flow control, mode of transfer. We will have this one. And then you will have urgent pointer. So URG is nothing but the urgent pointer. And ACK is nothing but the acknowledgement number, which is a valid acknowledgement number. Okay. And then PSH, which is nothing but push. RST, it is going to reset the connection. SYN, synchronize the sequence number. FIN, finish or maybe terminating the connection. Then you will have window size. So that's nothing but the window size of the sending TCP in bytes. And then checksum, especially for error control. So that is actually very, very important in TCP rather than in UDP, user data protocol. And then you will have urgent pointer. So it's going to point to data that is going to urgently require, that needs to reach the receiving process at the earliest. So which means that the value of the field is added to the sequence number in order to get the byte number of the last urgent byte.